can a transformer convert direct current voltage when we learned the definition of transformers before? The definition says that a transformer is a device that converts a voltage level of AC power into another voltage level of AC electrical energy. So why can a transformer transform alternating current but not direct current? Let's combine the structure of the transformer to understand the principle of transformer voltage transformation. We know that transformers are mainly composed of iron cores and windings wrapped around the core. When an AC current is applied to the primary winding, the primary winding generates an alternating magnetic flux. The alternating magnetic flux through the magnetic conductivity of the iron core, forming a closed magnetic circuit in the core. The alternating magnetic flux passes through the secondary winding. An alternating electromotive force is induced in the secondary winding. According to this process, we can see that transformers mainly apply the principle of electromagnetic induction, which is the principle of electromagnetism. Now we understand why transformers cannot transform direct voltages. Let's take a look. When a direct current passes through the primary winding, because the magnitude and direction of direct current do not change, therefore, the magnetic flux generated by the primary winding is also constant. This magnetic flux through the magnetic conductivity of the iron core passes through the secondary winding because the magnetic flux does not change. Therefore, the secondary winding naturally has no induced electromotive force. When an alternating voltage U1 is applied to the primary side, and the current flowing through the primary winding is I1, what is the induced electromotive force in the secondary winding? Based on Faraday's and electromagnetic induction law and other theorems, scientists' windings have come to the conclusion that the secondary winding's induced electromotive force of the transformer is related to the number of turns of the primary and secondary. That is, the voltage is proportional to the number of turns. The current is inversely proportional to the turns. The size of impedance is proportional to the square of the turns. Okay, that's all for today's content. Let's review the learning content just now. We learned the principle of transformers. We know that transformers mainly works based on the principle of electromagnetic induction. It only works in AC circuits. The primary side and secondary side voltages of the transformer, D is proportional to the number of turns. The size of current is inversely proportional to the turns. The impedance is proportional to the square of the turns. After class, please think about this question. If the primary side of small capacity transformer with a rated value of 110/36V is to the 110V DC power supply, what will happen on the secondary side? Okay, that's all for this class.